Okay, let's see what is the sequence. A sequence is nothing more than a list of numbers written in a specific order. Okay, so sequence is a list which written those numbers in a specific order. The list may or may not have infinite number of terms in them, although we will deal exclusively with infinite sequence in this class. Okay, so there are sequences called infinite sequence and finite sequence. So in this lesson, we are going to discuss both. Before that, first we need to identify what are the notations we use for the sequence and what are the terms and how we write those terms and what are the names of the uh, components of the sequence. Okay, general sequence terms are denoted as follows. Here in the sequence, this is the sorry. These are the terms in the sequence. A1, this is the general notation. A1 first term, A2 second term, up to AN nth term. Then AN plus 1, N plus 1 term, like that. Okay. So here we call sequence is a set of numbers called terms arranged in some particular order. Now that is the sequence. So there are some notation to represent a sequence. This is the one way to represent the sequence. So we can put that as a list. A1, A2, up to AN to infinity. So this one is a infinite sequence. And here also this is the representation of sequence. Here we have only one that one represent as AN. So when n goes to 1 to infinity, we can write this sequence as this. These three notations are the representation of a sequence, same sequence. Here this upper limit and lower limit are like in this third one. The meaning of this in way this will be start with n equal 1 and end with n equal infinity. So this is the that notation. When n goes to 1 to infinity, what are the terms of the sequence? That a n. So here we have three representation of the sequence. So we can use any representation, any of these representation to write the sequence. And here these limits are not represented, but when we have this kind of one, we have to we can take n goes to 1 to infinity. Okay, so there are some examples to represent the sequences. So look at the first one. When n goes to 1 to infinity, an will be n over n plus 1. So we can find the term substituting 1, that is 1 over 1 plus 1, 1 over 2. That is the first term of the sequence. So to find the second term, substitute 2 instead of the n. Then 2 over 2 plus 1, that is 3. Then to get the third term, substitute n equal 3. That means 3 over 3 plus 1, that is 3 over 4. So similarly, we can find the infinitely many terms. Here an equal n over n plus 1. Okay, according to this notation. So in here also we can find similar to that. So what is the first term? What is the first term? That is n equal 1. Then 3 to the power 1. Here 3 to the power 1. Then minus 1 to the power 1, that is minus 1. And 1 plus 1, that is 2. Then minus 2 is the denominator. 3 is the minus 2 is the numerator. 3 is the denominator. Then minus 2 over 3 is the first term of this sequence. Then how to find the second term? Substitute 2 instead of the n. Minus 1 to the power 2, that is plus 1. 2 plus 1, that is 3. So numerator is 3. Here we have 3. So 3 to the power 2 is the denominator, that is 9. Is it clear? So according to this, we can find any term if we have this an. So here you can see there's a difference between these two, because here n start with 3. Sequence can be start with any number, any positive integer. That means sequence can be start with n equals 0. Sequence can start with n equal 3, n equal 2, n equal 1, n equal 10, or whatever the integers sequence can be start. But if we have that kind of a special sequences, the starting value and initial value will be given. Okay, so here n start with 3, here n start with 0. So now look at this. This one is example. Write the first 6 term of the sequence an equal 2n plus 3. So now you can see the first term, second term, third term up to 6th term. So here substitute the 1 to the n. Then you can get the first term. Similar to that, you can find the terms of the sequence. Next one. Write down the first few terms of each of the following sequences. So you can do this at home. Substitute the n 1 to find the first term, n equal 1, and n equal 2 find the second term. And if you substitute n equal 1 here, 1 plus 1 equal 2 over 1 to the power 2, that is 1. That means 2 is the first term. So like that. And here we have a minus 1 to the power n plus 1. So when you do this calculation, you have to be careful because there is a minus 1. You know when, and this one start with 0. So if you consider first term, when n equals 0, 0 plus 1 equal 1. Then minus 1 to the power 1 equal minus 1. Okay, minus 1 over 2 to the power 0. So you know when we have a power of 0 for any number, that is 1. Then minus 1 over 1. That is the first term. So how you find the second term? You had to substitute n equal 1. To find the first term, substitute n equals 0. To find the second term, substitute n equal 1. Because here n start with 0. So when you substitute n equal 1, then 1 plus 1 equal 2. Minus 1 to the power 2 is a 1. Because when you have even powers, we know this negative will be a positive. And here 2 to the power 1 equal 2. Then we have 1 over 2 like that. Okay, you have to try this one. I will, if we have any difficulties, we can discuss on the next session. Okay. So then, now we are going to learn the domain and the range of the sequence. Okay. A function whose domain is a set of consecutive integers. You know the function. Function whose domain is a set of consecutive integers. List of ordered numbers is separated by commas. Okay, I will explain this one after this. Each number in the list is called term. Okay, so here you can see this one is a finite sequence 2, 4, 6, 8, 10. So now this one is the first term. This is the first term. This one is the second term. Here you can see 2. This one is the third term. This one is the fourth term. This one is the fifth term. So when this one goes to infinity, we can count the terms. We call these terms as the domain of the sequence. So these are the set of consecutive numbers. Consecutive means 1, 1 plus 1, 2 here, 2 plus 1, 3, 3 plus 1, 4 like that. So relative position of each term 1, 2, 3, 4, 5 based on this sequence usually begin with position 1 unless otherwise stated. Always this one start with 0 if the 1 if the starting point is not mentioned. Okay. So we call these terms, this set of numbers, these consecutive numbers as the domain of the sequence. So most of the time this will be a common domain for any sequence. When you consider a range, that what is the range? So when we have a function, we know that are the outputs of the function. So here you can see according to these terms, we have the terms of the sequence. So those are the outputs. Then we call these are the range. The actual terms of the sequence are the range. Okay. This one is not very much important, but we have to have this idea about this domain. There is a domain and the range for sequences also. Okay. So this one also represent the terms. That means domain of each term. So we call this as range. This as domain. So n represent the domain. An represent the range. The next one. Finite sequence and infinite sequence. Sequence can be finite or infinite. Now already you have that idea, but this one represent the both finite sequence. There are only finite. Okay, so the sequence has. So here we have a finite sequence and infinite sequence. The sequence has last term of final term. That means there's a last term, but we call that those sequence as finite sequence. Now here the sequence continues without stopping. So that means we call this as infinite sequences. Now we are going to learn the, actually this one is already you know because you learn these things in O-level class for the mathematics, arithmetic sequence and geometric sequence. So we call this as Samantara Shreni, Sahagunottara Shreni. I think you know these two sequences. You are familiar with these. So this is the refresh. This one is a refresh for that memory. The arithmetic sequence is a sequence with difference between two consecutive constant d. Okay. Arithmetic sequence is a sequence with difference between two consecutive terms constant d. The difference is called common difference. Okay, so now this one is the arithmetic sequence which have a common difference for each consecutive terms in the sequence. So how we find that common difference? So get the difference between two consecutive numbers. So always you have to get the difference by if you consider this one as first term and second term, so get the d by 5 minus 2. That means you have to get the reduction first term by the second term. So if we consider another two consecutive number terms, third term and the fourth term, so you have to get the difference between fourth term minus seventh term. So we have a same common difference. Sorry, here there is a mistake. this must be 3 actually. First term must be 3, then 5 minus 3 equal 2. 7 minus 5 equal 2. 9 minus 7 equal 2. And 11 minus 9 equal 2. So 13 minus 11 equal 2. So similar that here common difference is 2, not the 3. So sorry for that, there's a mistake. If I write this one. So this will be 3. So common difference will be 2. This must be 3. Okay. So there's a mistake. Sorry for that. So now common difference equal to if you consider any consecutive integers, so we have the same common difference. So we call those as arithmetic sequences. When you consider geometric sequence, so there is a common ratio, not the common difference. So how you get the common ratio? You have to get the fraction. You have to get the quotient of two consecutive numbers. You have to divide second term by the first term. You have to divide the third term by the second term. You have to divide the fourth term by the third term. So like that, if you consider, if you know this one is a geometric series, if you ask to find the common ratio, so you can consider any two consecutive numbers and get the fraction. So here if you divide 4 over 2, that is 2. So here common ratio is 2. Okay. Then now there's an example based on the previous content. Consider the following sequence. Write down whether each sequence is arithmetic or geometric. So now these are the answers. First one is arithmetic. There's a common difference as 5. Second one is geometric. There's a common ratio. Third one is geometric. There's a common ratio because 12 over 24, that is half. That is the common ratio. And for the part D, so you can see this one is arithmetic. So difference is 51 minus 55, that is minus 4, or 47 minus 51, that is minus 4, similar to that. So here we have arithmetic sequence. In the part E, this one is not arithmetic or geometric because we cannot find the common difference or common ratio. Okay.